Mediterranean cyclone climatology and climate change. Cyclogenesis is the scientific name of the process leading to the development and strengthening of cyclonic circulation in the atmosphere. Cyclogenesis is particularly frequent in the Mediterranean basin, so much so, in fact, that it is one of the most cyclogenetic regions in the world. Early studies in the 1950s highlighted the high frequency of cyclogenesis in the Mediterranean, and in later years, more precise climatological aspects have been unveiled. The number of cyclones varies significantly among climatological studies, from hundreds to even thousands of occurrences per year. However, there is a strong consensus on the spatial and seasonal variability of the tracks of intense Mediterranean cyclones. Mediterranean cyclones have a clear seasonal preference of occurrence during the cold months, with maximum frequency in the winter. Climatological studies have also focused on the most intense cyclones, which are formed mainly in the northwest Mediterranean, between the Tyrrhenian and Adriatic Seas, close to the Atlas Mountains, in the Ionian or Aegean Seas, or near Cyprus. These cyclones occur with the greatest frequency in autumn and winter.
Eastern Mediterranean cyclones are very similar to cyclones in the rest of the Mediterranean, but there are also some differences. They form and they actually peak in winter compared to autumn and winter seasons in the other parts of the Mediterranean. They start or they form in the central Mediterranean or the eastern part of the Mediterranean, south of Turkey and close to Cyprus. And they also have a different precipitation impact. They have a different sources for the moisture. Some come from the Mediterranean itself, some come even from southern locations in the tropics, but mostly in the Eastern Mediterranean, whereas cyclones in the other parts of the Mediterranean can have even moisture coming from the Atlantic Ocean. Also, the precipitation impact can be different. Most precipitation falls in the Eastern Mediterranean after the passage of the cold front, and it's mostly convective even then. So yes, we have cyclones all over the Mediterranean, but there are also some differences.
Given their impact, Mediterranean cyclones have been studied for a long time. While they are, on average, less intense and smaller than extratropical cyclones that develop over the open oceans, Mediterranean cyclones play a dominant role in modulating regional precipitation and contribute more than 70% to total annual rainfall. They are responsible for the majority of climatic extremes in the Mediterranean region, and they heavily impact both the environment and the populations living there. Mediterranean cyclones with strong circulation, embedded convection, and frontal structures produce high-impact weather like heavy rainfall and flooding, thunderstorms with intense lightning activity, windstorms and dust storms, storm surges and landslides, as well as the compounding effects when these events occur in tandem. Both weak and intense Mediterranean cyclones are capable of producing large amounts of precipitation. Intense cyclones may contribute between 60% and 90% to regional extreme rainfall.
Well, intense Mediterranean cyclones come in a range of sizes and a range of physical mechanisms responsible for their formation, which determine their characteristics, including seasonal cycle. Well, all this condition our ability to analyze the impact of climate change on intense Mediterranean cyclones. Further analysis and investigation is needed. However, some advances have occurred over the last decades. When intense cyclones occur mainly anchored to the lee of prominent mountain ranges, such as the Alps or the Atlas ranges. In fact, you can find intense cyclones in Tyrrhenian and Adriatic seas, the Ionian Sea, Aegean Sea, Black Sea, and also Cyprus cyclones are very intense and frequent. Regarding the impact of climate change on intense cyclones, caution must be used because results so far are highly sensitive to the methodology used. But the consensus seems to indicate an overall decrease in the frequency and intensity of intense cyclones by the end of the 21st century, although there seems to be signs of an enhanced risk of extreme violent storms such as hurricanes. Overall, more research is needed to tackle these problems.
In recent decades, major Mediterranean cyclone research efforts have focused not only on atmospheric and climate science, but also on environmental and socio-economic impacts. New modeling capabilities and observational data sets have been made available to the scientific community, and new insights have emerged from interdisciplinary studies. For instance, key questions about cyclone interactions between the Mediterranean Sea and aerosols are being addressed, showing a strong effect of cyclones on regional environments and the water cycle. Several recent studies have also investigated current and possible future changes in cyclone frequency and intensity due to global warming. This topic is particularly relevant in the Mediterranean because it is considered particularly vulnerable to climate change. Most of these studies agree that a decrease in cyclone activity over the Mediterranean is expected, but these results still contain a certain amount of uncertainty, not least because they rely on estimates of future CO2 emission scenarios.
Intense cyclone in the Mediterranean is a very frequent weather system. They're responsible for the majority of high-impact weather, and what we know for many years now is that their number tends to decline. It means that every year, of course, we have different number of cyclones, but the general tendency is to get less intense cyclones. And this is good news from the perspective of high-impact weather, but on the other hand, this means less precipitation in the region, and this affects a lot the water cycle and the regional climate. Regarding climate change and the future evolution of cyclones, unfortunately there are not many studies that focus on this subject. And actually there is a large uncertainty between the models that predict the future climate. So we need more studies on this issue. On the other hand, what is quite certain is that we expect the number of the tropical-like cyclones in the Mediterranean, so the cyclones that attain comparable intensity to the actual tropical cyclones, to decline. It means less tropical-like cyclones in the future. But on the other hand, we expect the intensity of these tropical-like cyclones to rise. So we expect stronger windstorms and more extreme precipitation. And one of the main reasons behind this evolution on the intensity of the cyclones is the rise of the sea surface temperature in the Mediterranean, which means more evaporation, so more water vapor in the atmosphere, and eventually more energy for the cyclones to develop in catastrophic storms.
Among several recent studies, a group of researchers conducted a 40-year analysis of cyclone activity in the eastern Mediterranean and found a negative trend, especially for winter cyclones. This negative interannual trend was consistent with the results of a previous study focused on the most intense systems. Other studies, based on model simulations, tried to analyze the future trend for Mediterranean cyclones through the end of the century. For example, one study found a decrease in the frequency of cyclones throughout the Mediterranean basin, supported by the consensus of all models used in the study and consistent with other previous results. A more recent study showed a reduction in cyclones in the eastern Mediterranean, while another suggested an overall reduction in both the number and intensity of intense Mediterranean cyclones for the same period. On the other hand, recent studies show that cyclones known as metacanes, particularly intense Mediterranean cyclones that resemble tropical cyclones, are expected to decrease in frequency, though higher sea surface temperatures may increase their intensity.